With the creditor application, I decided to take an Azure serverless approach. That included both an Azure static website and an Azure function. The static website is built with Vue.js and ES6, while the Azure function is built with C# and that itself communicates with the SQL Server database. Now let's get into some of the details that I used for both the front-end website and the back-end function. So the front end is a standard Vue.js CLI project built with ES6. I split the application into a top-level creditors component and add creditors component to add the new creditors, a summary creditors component to show aggregate data, and a notifications component which displays a snack bar when creditors are added or deleted. Data is managed and shared across these components using Vuex and persisted in local storage via Vuex persist, and that comes in handy if a page refresh occurs. Data access is provided by a creditor service for any API interaction, and that goes through Vuex actions. The creditor service uses the Axios library to make its API calls, and I am using Vuetify for component styling, which is a material design UI framework. This provides much of the layout that I need, but I am also using some CSS Grid and Flexbox where necessary. The creditor app itself is published to GitHub and automatically deploying and building to an Azure static website. The backend for the creditor application is an Azure function written in C#, and the data is stored in a SQL Server database. I created 3 endpoints in the Azure function. There is the get all creditors endpoint, the delete creditor endpoint, and the add creditor endpoint. The application architecture for this Azure function is a standard 3-layer architecture. It contains Azure function classes, which communicate with a service class, which then communicates with a repository class. There's also a single creditor domain object, which is used throughout the application. And I'm using Entity Framework to communicate with SQL Server. And with Entity Framework, I'm using a code-first approach. With the creditor web application, I didn't come across many challenges on either the Vue.js website or the backend function, but I could imagine where there would be challenges to implement an application like this in production. For example, managing credit card data would require paying special attention to transactional consistency. It's possible that serverless web apps and functions may not be best suited to guarantee accurate data calculations for this kind of information. And in that case, I would consider pushing calculations like these to the database rather than in the web app or the API. To architect this application to allow users to simultaneously edit the data and see each other's changes, I would consider employing additional defensive validation, and to see the simultaneous changes, I'd consider a technology such as sockets.io for messaging. The additional defensive programming would be added around the add and delete calls, and I would just use this to verify that data has not changed before I push out more changes. A similar tactic could be used in the Azure function to handle inconsistencies like this. To view other users' changes, an additional API using sockets.io could be used to handle messaging when a specific event occurs on a user's data. This could be used to both notify the user when data has changed and also indicate when the front-end application needs to update its data. Now let's get to the demo. During the demo, I'm going to walk through fetching API data, rendering credit data in the table, adding debt, removing debt, doing a select all, deselect all, individual selections, selected row count, balance total based on selection, and the total row count. So first I'm going to show fetching the API data. Now this actually is coming off cached data right now, but if you were to initially hit this website without visiting it recently, it's going to pull down data from the API. And you can see we're rendering that data, the creditor data, in the data grid here. Next, I'm going to try and add a new creditor. And test first name, test last name, 3%, and a balance of $235.25. So I'm going to go over and click that icon to commit the data. You can see that our data just showed up in the final row. Now I'm going to try and remove data. So I can go over here to the trash can, click that, and it removes the data. Just to do a quick double check, we can do a refresh, and we can see that that data is actually gone right now. Now let's go on and check out the select all, deselect all. From up here, we can select all and deselect all. When we select all, we will notice that the total balance down here does reflect all of the balances in the data grid. You can see over here the selected rows are reflected in that too. So now we can test the individual selections. So now with everything selected, let's just pull one off. And we can see that the balance is going down and the selected rows are also going down. We can do this with maybe just one or two items. You can see it incrementing. And just to close it up, you can see that the total row count does show the total rows inside of the data grid. I just wanted to thank you for taking the time to look over the interview test and for watching this demo. Feel free to reach out to me if you have any questions, and I will add links to the Creditor app site and the GitHub repo for its source code in the description below. Thanks again for watching.